The metallic screech of tank treads echoed through the frozen Belgian forest as Oberleutnant Hans Becker pressed his eye against a viewing port. What he saw made his breath catch in his throat. There, abandoned at the edge of a snow-covered field, sat a beast that had become the nightmare of every Wehrmacht soldier, an American M4 Sherman tank. Track damaged but otherwise intact. It was December 1944, and finding such a prize was like discovering gold in the rubble of a crumbling empire. Becker's hands trembled slightly as he radioed his superior. This wasn't just any tank. This was a gateway to understanding the mechanical monster that had been crushing German positions across Western Europe. Within hours, a recovery team arrived, their faces a mixture of excitement and grim determination. They knew what this capture meant, or rather, what they hoped it would mean for Germany's desperate war effort. The Sherman was carefully towed back behind German lines' destination, the weapons testing facility at Kummersdorf. Every kilometer of that journey felt surreal to the soldiers tasked with moving it. Here they were, transporting American engineering excellence while their own panzer divisions were grinding to a halt for lack of fuel, spare parts, and functional vehicles. If you're fascinated by the untold stories of World War II engineering and desperate measures, you're in the right place. Subscribe and join us as we explore the moments that changed history. When the Sherman finally arrived at Kummersdorf, Chief Engineer Wilhelm Strauss assembled his best technical team. These men had spent years designing and analyzing German armor. The fearsome Tigers, the powerful Panthers, the experimental super heavy tanks that existed more on drawing boards and battlefields. Now, they would dissect American ingenuity, bolt by bolt. Strauss walked slowly around a captured tank, running his hand along its sloped armor. The team began their work with methodical precision, photographing every angle, measuring every plate thickness, documenting every weld. As they removed the engine covers, what they found inside would fundamentally shake their understanding of industrial warfare. The Sherman's engine was a modified civilian automobile engine, not some purpose-built military powerhouse, but an adapted commercial design. Strauss stared at it in disbelief. The transmission was equally straightforward, robust, yes, but simple, manufactured using techniques that prioritized speed of production over technical sophistication. The team discovered something that sent chills down their spines. This tank was designed to be built quickly, repaired easily, and replaced rapidly. One of the junior engineers, Friedrich Kemper, voiced what everyone was thinking. Herr Strauss, this is not a masterpiece of engineering. This is a product of industrial assembly. Strauss nodded grimly. That was precisely the problem. While Germany had been perfecting the art of creating individual mechanical masterpieces, tanks that required hundreds of man-hours and rare materials, America had been perfecting mass production. The team continued their examination, removing panels, testing mechanisms, analyzing metallurgy. The armor quality was adequate, but not exceptional by German standards. The gun was effective but not revolutionary. Everything about the Sherman screamed one philosophy: good enough to win, simple enough to build by the thousands. As the winter darkness fell over Kummersdorf that evening, the engineers compiled their preliminary report. What they had discovered wasn't just about one tank. It was a revelation about two completely different approaches to war, and a terrifying glimpse into why Germany was losing. The detailed analysis continued into January 1945, and with each passing day, the findings became more disturbing for the German engineers. Strauss ordered comprehensive testing of every system, pushing the Sherman through trials that would reveal its true capabilities and limitations. What emerged was a portrait of industrial philosophy that stood in stark contrast to everything the Third Reich had built its armored doctrine upon. The suspension system particularly caught their attention. The Sherman used a vertical volute spring suspension, a design that was neither sophisticated nor particularly smooth. German engineers had developed far superior torsion bar systems that provided better ride quality and durability. Yet, as they tested the American suspension over rough terrain, they discovered something unsettling. When components broke, they could be replaced in hours using basic tools. A German Panther tank with suspension damage might require days in a workshop with specialized equipment. Kemper spent 3 days examining the electrical systems. He discovered standardized wiring, clearly labeled junction boxes, and replaceable fuse panels. Everything was designed for a crew that might have only weeks of training. In contrast, German tanks required technicians who understood complex systems built with precision but little thought to field maintenance. The American approach treated tanks like they treated everything else in their industrial arsenal, as tools that average soldiers could operate and maintain. The weapons testing range at Kummersdorf echoed with the crack of the Sherman 75mm gun. Strauss personally observed as they fired round after round, measuring accuracy, reload times, and mechanical reliability. The gun itself was not particularly impressive by German standards. A Tiger's 88mm gun was far more powerful. A Panther's 75mm high-velocity gun had superior penetration, but the Sherman's gun worked consistently and reliably, and that was its genius. During one firing exercise, a component in the gun's recoil mechanism malfunctioned. The German crew expected hours of repair work. Instead, they consulted the captured technical manual, written in clear, simple language with detailed illustrations, and had the gun operational again in under an hour. Strauss watched this with a mixture of admiration and dread. American tanks were designed for an army of millions, not an elite corps of specialists. The fuel consumption analysis revealed another philosophical divide. The Sherman's gasoline engine was thirsty compared to diesel alternatives, but gasoline was what America had in abundance. Germany's sophisticated diesel engines for tanks were theoretically superior, but fuel scarcity made them increasingly irrelevant. The Americans had built their war machine around their strengths, not around theoretical perfection. As February arrived, Strauss compiled the final sections of his report. He sat in his office at Kummersdorf, surrounded by photographs, technical drawings, and metallurgical analyses. The document he would prepare would go directly to the highest levels of military command, and its conclusions were damning not to American engineering, but to German strategic thinking. The Sherman tank, he wrote, represented adequate technology deployed with overwhelming industrial capacity. For every Panther Germany painstakingly produced, requiring rare metals and hundreds of skilled labor hours, America built 5 Shermans using standardized parts and assembly line techniques. For every Tiger that broke down far from repair facilities, 20 Shermans remained operational because any mechanic could fix them. Germany had been fighting a craftsman's war in an age of mass production. Strauss included comparative production figures that intelligence had gathered. In the time it took Germany to build one Tiger tank, American factories produced approximately 18 Shermans. The numbers were staggering and illustrated a fundamental truth the German High Command had been unwilling to face. Technical superiority meant nothing when you were outnumbered 10-1. The report's most devastating section analyzed Germany's current industrial capacity. Strauss had consulted with colleagues across the armaments industry, and the picture they painted was catastrophic. Allied bombing had crippled ball bearing production. Skilled workers had been drafted into infantry units to stem the collapse on the Eastern Front. Raw materials were increasingly unavailable. Meanwhile, across the Atlantic, American factories operated at full capacity, untouched by war, producing tanks faster than Germany could destroy them. The completed report landed on the desk of General Oberst Heinz Guderian in late February 1945. Guderian, one of Germany's most accomplished tank commanders and now chief of the General Staff, read Strauss's findings with a growing sense of fury and despair. Everything the engineer had documented confirmed what Guderian had been arguing for years. Germany had lost the industrial war before the first Panzer ever crossed into Poland. Guderian called for an emergency meeting with representatives from the Reich Ministry of Armaments and War Production. The conference room in Berlin was cold, heating fuel being yet another scarce resource in the dying days of the Reich. Albert Speer, the Minister of Armaments, arrived with his senior advisors, their faces already showing the strain of managing an economy that was collapsing in real time. Strauss presented his findings with clinical precision. He showed photographs of the Sherman's simple construction, demonstrated with captured parts how easily components could be replaced, and explained the fundamental philosophy behind American tank design. The men in that room had built their careers on the belief that German engineering superiority would overcome any disadvantage in numbers. Now they faced mathematical proof that their assumptions had been catastrophically wrong. Speer listened in silence, his expression unreadable. When Strauss finished, the minister spoke quietly. "How many Panthers can we produce this month?" An aide consulted his documents and replied with hesitation. "If we experience no further bombing raids and if raw material deliveries continue, perhaps 150 units. Speer nodded grimly. "And how many tanks will the Americans produce this month?" The room fell silent. Everyone knew the answer was measured in thousands. Guderian slammed his fist on the table, startling the assembled officers. "For years I've been saying this. While we perfected the Tiger, the Allies buried us in Shermans and T-34s. Every hour we spent making one tank perfect. They spent making 10 tanks good enough." His outburst was uncharacteristic, but the frustration of watching predictions come true was overwhelming. The other officers shifted uncomfortably, unwilling to acknowledge their complicity in the strategic disaster. The discussion turned to Germany's current production capabilities, and the numbers were devastating. The ball-bearing factories at Schweinfurt, repeatedly bombed by Allied air raids, were operating at a fraction of capacity. This single bottleneck affected every piece of complex machinery the Reich tried to produce. Tank production, aircraft manufacturing, even U-boat construction, all were constrained by the shortage of precision components that required specialized facilities and skilled workers. Speer produced his own reports, detailing the cascading failures across German industry. The synthetic fuel plants were priority targets for Allied bombers. Without fuel, the most sophisticated tank in the world was just an expensive pillbox. The steel mills were running out of quality or forcing manufacturers to use inferior materials that resulted in armor plates that cracked under stress. Skilled machinists were being drafted into infantry units because the Eastern Front was collapsing and needed bodies more than the factories needed expertise. One of Speer's deputies raised a question that had been haunting the armaments ministry. Could we not simplify our designs? Build something like the Sherman, simple, mass-producible? Strauss shook his head. It is too late. Such a redesign would take months we do not have, and even if we completed it, we lack the industrial infrastructure for true mass production. American factories are built around assembly lines and standardization. Our facilities are designed for precision manufacturing in smaller batches. The meeting concluded with a sense of hopeless inevitability. Guderian returned to his headquarters, the captured Sherman report tucked under his arm. He knew that even this stark evidence would not change the minds of the fanatics who still believed in miracle weapons and final victories. The V-2 rockets, the jet fighters, the super heavy tanks that existed mostly on paper, all represented the same flawed thinking that had produced the engineering marvels that were now losing the war. At Kummersdorf, the captured Sherman sat in a testing bay, its mechanical secrets fully revealed. Junior engineers still came to examine it, taking measurements and photographs. But the initial excitement had faded, replaced by a somber understanding. This tank, so unimpressive by German standards of engineering excellence, represented something far more dangerous than any individual weapon. It represented an industrial system that Germany could never match and could no longer defeat. By March 1945, the captured Sherman had become an unintended monument to everything Germany had misunderstood about modern warfare. While Strauss's report circulated to the highest levels of command, the tank itself remained at Kummersdorf, occasionally visited by officers who wanted to see with their own eyes what American industrial power looked like up close. Each visitor left with the same haunted expression, finally comprehending the magnitude of Germany's strategic miscalculation. Kemper had been assigned to continue documenting the Sherman's features for a training manual that would help German crews exploit any weaknesses if they encountered these tanks in battle. But as he worked, he found himself thinking less about tactical advantages and more about the profound differences in national character that the tank represented. Every bolt, every weld, every design choice spoke of a country that understood warfare as an industrial problem requiring industrial solutions. The younger engineer began comparing German and American tank production philosophies in his personal notes. A Tiger tank required approximately 300,000 man-hours to produce. The complex overlapping armor plates had to be precisely fitted. The sophisticated transmission needed specialists to assemble. The optical equipment demanded jeweler-level precision. The result was undeniably a superior fighting vehicle, when it worked and when it had fuel, and when spare parts were available, and when trained crews could operate it. The Sherman required approximately 10,000 man-hours to produce. Its armor was simple rolled plate, welded together by workers who might have been building automobiles 6 months earlier. Its transmission was robust but basic, designed so that any competent mechanic could repair it with standard tools. Its sights were adequate rather than exceptional. The result was a tank that was good enough for the job and could be built in vast numbers by an industrial workforce that prioritized volume over perfection. In late March, word reached Kummersdorf that Soviet forces were approaching from the east while American and British armies closed from the west. The facility began preparations for evacuation. Strauss received orders to destroy sensitive documents and equipment that could not be moved. The captured Sherman presented an unusual problem. It was too valuable as intelligence to leave intact, but there were no resources to transport it. Strauss made the decision personally. The Sherman would be destroyed. It felt oddly symbolic, this act of demolishing a tank that had already served its purpose of revealing uncomfortable truths. On a cold morning in early April, engineers placed demolition charges inside the hull, carefully positioned to render the vehicle completely inoperable. Kemper watched from a distance as a superior personally set the detonation sequence. The explosion was anticlimactic. The charges destroyed the internal mechanisms without creating the dramatic fireball that propaganda films had trained everyone to expect. The Sherman sat there afterward, externally intact but internally ruined. Just another piece of wreckage in a war that had produced mountains of destroyed machinery. Strauss turned away without ceremony and ordered his team to prepare for evacuation. As the engineers packed their essential documents and equipment, they could hear the distant rumble of artillery. The Red Army was getting closer. Strauss ensured that copies of his Sherman analysis were distributed among the departing staff. Though he wondered what purpose they would serve now, the war was lost, and the lessons learned from one captured tank were relevant to a Reich that would cease to exist within weeks. Kemper took one final walk through the testing facility before they departed. He passed by workshops where Germany's most advanced prototypes had been evaluated, past firing ranges where the latest weapons had been tested, past offices where engineers had calculated trajectories and armor angles with mathematical precision. All of it had been impressive. All of it had been insufficient. The young engineer understood now what Strauss had been trying to articulate in his report. Germany had approached warfare as a technical problem requiring technical solutions. They had built better tanks, better guns, better optics, but America had approached warfare as an industrial problem requiring industrial solutions. They had built adequate tanks in overwhelming numbers, supported by a logistics system that kept them fueled, armed, and operational. On April 21, 1945, Soviet forces overran Kummersdorf. Among the wreckage and abandoned equipment, they found a destroyed Sherman tank. A Soviet officer, recognizing American manufacture, assumed it had been captured for propaganda purposes. He was partially correct. The tank had served a propaganda function, though not the one he imagined. It had forced Germany's military leadership to confront the reality of their industrial inadequacy, though the revelation came far too late to change anything. The lessons from that one captured Sherman, about industrial capacity, about design philosophy, about the relationship between technological sophistication and strategic victory, would influence military thinking for decades. But in the spring of 1945, those lessons were simply epitaph for an empire that had confused engineering excellence with strategic wisdom, and had paid for that confusion with total defeat.